Today we're going to talk about properties of chords in circles. So remember that a chord is a segment that extends inside the circle. It has endpoints on the circle, a chord. Alright, so the first rule, I think we've talked about, congruent chords intercept congruent arcs. So right here, if these two chords are congruent, then I know that the two arcs that are intercepted are also congruent to each other. The next rule says if a diameter is perpendicular to a chord, I believe we've talked about this one too. If a diameter is perpendicular to a chord, it bisects the chord and the arc. And I think we have looked at this before, but this time we're going to be looking at it in terms of right triangles. We're going to draw a radius here, and then we'll use the Pythagorean theorem to solve some of our problems involving the right triangles. The next one says if chords are equidistant from the center. So if I measure the distance from the center to this chord, remember the distance we measured is always perpendicular. That way we get the shortest distance. If I measure that distance, and then I measure this distance, and they happen to be the same, they're the same distance away from the center, then those two chords are congruent to each other. So if chords are equidistant from the center, they are congruent. And this rule is brand new for this lesson. If two chords intersect, they're going to intersect inside the circle. Their segment lengths are represented by the following rule. If you did the notes in class, we discovered it, but this is A times B equals C times D. You multiply the segments of the same chord, so A times B, C times D, and you can solve for the missing piece. All right, let's take a look at some examples. The first one says, if M is the center of circle M, AB is 26, find X. If necessary, work it around to the nearest thousandth. So if AB is 26, then I know that this segment right here would have to be 13 because my diameter gets cut in half. So now I have a hypotenuse of 13. My chord right here, notice this is perpendicular to my chord, so my chord got cut in half. And now I just plug those into the Pythagorean theorem. 13 squared equals x squared plus 10 squared. So I'm going to grab my calculator. And if you want to shortcut this, some of you will figure this out. You could say 13 squared minus 10 squared, and then take the square root. If you don't like that, you can always write the work out the other way. So 8.3066, so we're going to round it to 307. So lots of Pythagorean theorem in this unit. Next question. M is the center again. E to M is 6. Now notice that ME is perpendicular to the chord. Now I realize that ME is not a diameter, but you know, imagine it's part of a diameter, so that counts. Perpendicular to a chord, it's going to bisect the chord. If AB is 30, so they've given me the diameter is 30, that means each radius is 15. Now I can draw a radius anywhere inside the circle, but I'm going to choose a helpful radius. So for example, I'm going to draw a radius from M to D, because that's going to create a right triangle for me. And then I can do the Pythagorean theorem to solve for the missing piece. Your radius is going to be the hypotenuse of the triangle. So on this one, 15 squared equals 6 squared plus x squared. We'll say this piece is x, and then we'll put it in our calculator. 15 squared minus 6 squared. And I get x equals 13.7477, and some more stuff. Now notice, I just found the distance from E to D. What was I asked to find? F to D. Well, I know ED is half because the segment was bisected. So I'm just going to take this answer from my calculator and multiply it by 2. And now I'm going to round to the nearest thousandth. So remember, we only round one time in the entire problem. So when you take this first number, keep the extra decimal places, multiply it by 2, and then you round to the nearest thousandth. We only round one time per question to keep our accuracy. All right, let's turn to the next page. Similar question. M is the center. AB is 18. Find DE. So notice that these two chords, AB and DC, are the same distance from the center. That means AB and DC are congruent. So if AB is 18, DC must also be 18, which makes DE half of that. DE equals 9. All right, number 4 is a challenging question. I'm going to put a star next to it because it's a very important question to know how to do. They've given us this information about circle M. Find AB to the nearest thousandth. So this question is going to require a couple of steps to get us to AB. So first off, I know that the radius is 20. Now the radius isn't in a helpful location, so I'm going to draw it in a helpful location to create a right triangle here. That's 20. From X to this point is 16. So I'm going to find this little piece right there using the Pythagorean theorem. So 20 squared equals 16 squared plus X squared. Put it in our calculator, just like we did the other two. And I find out that this little piece from M to here is 12. So ignore the scale because this section is 3 and it's way bigger than the section that's 12. But that makes this entire piece 15 from M to C. Now I'm going to draw another radius, but this time I'm going to draw it from M to A. So the radius anywhere inside the circle is always going to be the same. So this radius is 20. This leg is 15 because I added the 12 and the 3. And now I can find the distance from A to C by doing the Pythagorean theorem again. So 20 squared equals 15 squared plus y squared. We'll plug that into our calculator. And we get this amazing 13.228 number. Now remember, don't round it off yet because we're not done. The question said to find AB. We just found AC. So all I need to do is double it, and then I'm going to round off my final answer. So AB is going to be 26.458. So that's probably one of the harder questions, but I 100% guarantee that you will see this again. So pay close attention to that. And if you can do this, the rest of them are pretty simple. Lastly, number 5, and then you can go off and practice. Find the value of X. If two chords intersect inside the circle, then my rule says to multiply the pieces of one chord times each other and set it equal to the pieces of the other chord multiplied together. So this one's going to say 12 times X equals 7 times 9. So 12X equals 63. I don't know that that comes out to a beautiful number, so let's look. 63 divided by 12, oh, it's 5.25. So that's the value of X in this question. So that's an application of the rule. So you're going to be careful with your problems. For example, this first one, when you multiply, you're going to be using some algebra. So make sure you multiply correctly. When you do x plus 1 times 4x minus 2, many of you learned FOIL. Make sure you multiply everything to get your full answer and then solve. So do some practice problems and you'll be ready for your check.